All right, let's recap what we did yesterday, the last part of yesterday's lecture. We solved linear or polynomial inequalities. For example, something like this. Change all these signs. We have polynomial inequality. The first step, we have set equal to 0. It's not just straightforward. Since you have multiple terms on this polynomial, you always have to put it to where the highest degree is, because that's the part that's important. But as it says here, if the coefficient of the highest degree is negative, move that first, because you always want to have a positive in front of the highest degree. So in other words, I'm going to move this one over. That means everything else has to go to the right-hand side.
So it's the same concept of moving the smallest number?
Yes, because this is the smallest number. But the smallest number really, when you have two, if I had another x squared on this side, that's when you compare the two. But this one is, you don't want a negative. Because if I moved everything to this side and I had a negative, my next step is change all the signs, which means I also have to change the inequality. Too much to remember. So instead, just go ahead and move the one that has the negative sign on it. If the highest exponent has a negative, move that one, and then move everything else following it. So we have 0 on this side. It'll be positive x squared. Moving that one makes it a plus 3x. Moving that one makes it a negative 5. And we have what's on the other side already. So now we have everything on one side, and we have a positive coefficient. And then what you would do is combine like terms. 3x minus 1x is positive 2x. Negative 5, negative 3 is negative 8. And go ahead. Once you did that, set has equal to 0. You have a positive coefficient. Everything. Now go ahead and factor. So what we would do is 8. We'd go ahead and factor this one. So x and x. The second sign's a minus, so it's opposite signs. Bigger numbers are positive. What times what is 8? When you subtract them, you get 2. 4 and 2. Find the x-intercepts, in other words, solve them. X equals negative 4 and x equals 2. So that's that one. The next one says sketch the graph. We know our intercepts are at negative 4 and at positive 2. Since it's an equal sign in there, they're solid. We can include those values. Sketch the graph. Well, because we know the leading coefficient is positive, then we're thinking our graph looks like this. But the problem with this is it's not true. Because remember, what do we do first? We change the sign of x. So since the original x was negative, this is where we find the direction of the graph. It's going to be going, our graph will be going down.
What were you saying about like the top? I think the top of the graph is.
How do you mean? With respect to what?
Like, how do you know it's like, it goes down?
Okay, well, then that, okay, I'll get that in a second. Now, since this says 0 is less than this, so what we're looking for is any part of the graph that's above the x-axis. So since that's, we're looking for all the parts that are above. Yes, so let's look at it as a linear equation. If we had 3x plus 2 is less than 0. This percentage is a graph. So we're looking at this graph here. Here's our x-intercept, here's our y-intercept. So what we're going to look at here is, I want to know what part of the graph is below 0. And this is where 0 is, or y equals 0. Remember, this is our y value. So y0 is the x-axis. So I want to know every part of the graph that's below the x-axis. So it's from negative infinity to 0. My answer would be, that's what we're looking at. All right. So that was with polynomials. Now, with rational inequalities, we have an extra step that we have to worry about. Not only do you have to worry about set it equal to 0 and find out where the intercepts are, we now also have to worry about vertical asymptotes. What are vertical asymptotes? X values that make the denominator equal to 0, which makes it undefined. So we have to not worry about that. So let's look at these examples here. Example 5. Because all I want is what? What is this question asking me to find? Since it's 0 on one side, what am I looking for?
For X. What value X the graph will belong to.
Very good. We're looking for what X values makes the graph go below the x-axis. So do we even need the horizontal asymptote? Not really, but I mean, it's good to know since we use it already. If we sketch this graph, well, if there's no horizontal, then there could be an oblique asymptote. But if there is a horizontal, then there cannot be an oblique. It's either one or the other. If one exists. So what's my x-intercept? Remember, you have to find the x-intercept, find the y-intercept, the horizontal asymptote or the oblique asymptote and the vertical asymptote. So looking at this graph, what can you tell me? Any of these, can you tell me? No. How do you find the y-intercept? Set x equal to, you set x equal to 0, what do you get? Right, again, don't do it in your head. You have pencil and paper, use it. Because you're still in the process of learning math. What's the y-intercept? How'd you get that?
Bottom.
What's the step for finding the y-intercept? Set x equal to 0. If you set x equal to 0, what do you get? Plug it in. Don't ask me, tell me. If you plug in 0 for x, what do you get? 0. So the y-intercept is 0. 3 times 0 is what? 0 plus 6 is 0 plus 6, 6. 0 divided by 6 is 0. So that's my intercept. So I go through the origin. What else can you tell me about this? What's my x-intercept? How do you find the x-intercept? So the top equals 0. If 3x equals 0, what is x? Again, before you spit out an answer, work it out. So far, 90% of your spit out answers have been wrong. How do you find the x-intercept? On a fraction, it's always a top number. Set that equal to 0. 3x equals 0. What do? Solve for x. How? Divide by 3. So if you have 3x equals 0 and you divide by 3, what do you have? 0. Again, if you write it down, work it out, your answers will be much more impressive. Do we have a horizontal asymptote? If so, what is it? It was less than 24 hours we talked about horizontal asymptotes. Nope. Horizontal. If it's horizontal, it crosses which axis? The y-axis. So we can't have x equals. How do you find the horizontal asymptote? Look at your notes. See, this is the reason we're going so slow, because now I don't want to go to Tuesday. That's why I need you guys to start doing your part of the job. You look at the degrees, top and bottom. They're both the same, so they cancel. So it's just 3/1. So the horizontal asymptote is the line y equals 3. That's the horizontal asymptote. What's the vertical asymptote? And we don't have an oblique asymptote. Vertical asymptote, set the bottom equal to 0. So it's x equals -6. Actually, because I'm just going to pick up the pace, and that way I get right answers. So we have this graph. What's it going to look like? Well, since it crosses the x and y axis here, we know that this part has to be here. Because there is no other y-intercept. It can't cross up there. And the other part has to be here because there is no other x-intercept. So all I want is, where's the graph lower than the x-axis? it's from -6 to 0. Because it can't cross here. That's a vertical asymptote. So the only part it's below the x-axis is in this range here. So that's my answer. All right, let's do another example. Yeah, so I'm gonna get to a point. I'm not gonna ask questions. I'm just gonna lecture because I'm gonna try to finish chapter 5 before next Monday or next August. Example 6. X plus 1 over 2x minus 4 is less than equal to 1. What's my first step? Well, first step, set equal to 0. So I got to move the negative, move over the 1. So we have an x plus 1 over 2x minus 4 over 1 less than equal to 0. Since we're dealing with fractions, 1 is 1 over 1. In order to add and subtract fractions, I need common denominators. What's the common denominator? The only denominator we have is 2x minus 4. So I multiply this one by 2x minus 4 over 2x minus 4. So we have x plus 1 minus 2x minus 4 all over 2x minus 4 is less than equal to 0. Do I need the first parenthesis? No, because there's no coefficient. The second one, I distribute the negative sign. So -1 times 2 is -2x, -1, -4 makes it a +4. I got rid of parentheses, so I combine like terms. So on top, you have x minus 2x is -x. +1, +4 is a +5. So there's my polynomial. We are now looking for the x-intercept, the y-intercept, the horizontal asymptote, oblique asymptote, and vertical asymptote. The x-intercept. The only way I can make an x-intercept is set the top equal to 0. I set the top equal to 0. I get -x plus 5 equals 0. So x equals 5. That's my x-intercept. So I know it crosses at 5. The y-intercept. Get rid of all the x's. I get 5 over -4, which is -5/4, which is -1 1/4. So it's approximately there. There's my y-intercept. Horizontal asymptote. Look at the leading coefficients. They're both the same degrees, so it's just in front. So it's -1 over 2, so it's -1/2. So the horizontal asymptote is at -1/2. Again, we talked about this within 24 hours ago. So we don't have an oblique asymptote. Vertical asymptote. I take the bottom, set it equal to 0, solve for x. So my vertical asymptote is at 2. Because we have a horizontal asymptote here and a y-intercept there and a so this part of the graph has to look like this. Has to be below the horizontal asymptote and it can't touch the vertical, so it has to go there. On the other side, there's an x-intercept. I cannot cross the y, so it has to look like this. It's just common sense because horizontal asymptote, that's what it approaches. Vertical asymptote, that's what it approaches. There's an intercept, has to cross, so it has to be that way. So my solution I'm looking for is where is this graph below the x-axis? Well, this whole part over here is from negative infinity all the way to 2. That's all below the x-axis. Where else is it below the x-axis? Well, we had a x-intercept there. So from 5 to infinity is also below the x-axis. Remember, x-intercepts is where it is on the x-axis. Anything, in this case, anything to the right of it is below the x-axis. Anything to the right, left of it is up above. Anything below is to the right. So that's my solution to this set. It helps if you know if you remember how to graph your functions.
Where no, there's a vertical asymptote, it would be to infinity.
What do you mean? The vertical asymptote?
Yeah, the y value. Look, as infinity, but
What? These are my x values. For this one, as x goes to infinity, this one gets lower and lower and lower. It's going lower and lower because the horizontal asymptote is at -1/2. So it's approaching that line. It crosses at 5. So from 5 to negative infinity or infinity, it's below the x-axis.
oh,
So all this here is below the x-axis. Yeah, it makes it difficult because the horizontal asymptote is so close to the x-axis. But what you're looking for, that's why the intercepts are important. At the intercepts, it's either to the left or to the right. One of them has to be above the x-axis. All right, the last one for this chapter. X minus 3 over x plus 4 is greater than equal to x plus 2, x minus 5. Does it matter which one you move? No. So which one do you want to move? Left to right or right to left? All right. So we'll move here. So that means we have to subtract x minus 3 over x plus 4 from both sides. Because we're moving the entire radical or rational. X minus 3 over x plus 4 minus x, this becomes a 0. And on the other side, I have x plus 2, x minus 5, minus x minus 3, x plus 4. That's how I write it.
you wouldn't go to there.
Well, as long as I have this one right here, I could put around each one of these separately. But as long as this is out there, that's why whenever you deal with anything like this, always keep the signs in front of the numbers. I said earlier, if it's an integer, then we could do that. But since this is an equation, I keep the negative sign out in front of the entire thing. But eventually I have to move it on top. And that's why the parentheses are important. Because my next step here is what? Because you're subtracting fractions, you have to have common denominators. So to this first one, it doesn't have an x plus 4, so I have to put x plus 4 over x plus 4. The first one has x minus 5, the second one doesn't, so I have to multiply x minus 5 over x minus 5. Why do I multiply, let's say, x minus 5 over x minus 5 to that side? Yes, but why x minus 5 over x? Why not just put x minus 5 on the bottom? Why? No, because if we multiply only to the bottom, then we're changing the number itself. What is x minus 5 over x minus 5? 1. When you multiply anything by 1, you don't change it. That's the reason whenever you multiply something, it has to be over itself. Because I'm multiplying by 1.
You're making them all the same value.
Right. So it's very important. You cannot change the numbers. You just change the way they look. So now on the bottom, we have x minus 5, x plus 4. We have a common denominator on the bottom. So on top, we have x plus 2 times x plus 4 minus x minus 3, x minus 5. Leave the bottom alone. Since it's already in prime factors, leave it that way. Now we have to multiply our terms. We have to get rid of the parentheses. So x times x is x squared. X times 4 is positive 4x. 2 times x is positive 2x. 2 times 4 is positive 8. And likewise on the other one. X times x is x squared. Negative 5x. Negative 3x. Positive 15. Again, we've been doing this for 2 chapters now, so I'm not going to explain what's going on. We should know it already. Once you get rid of parentheses, always combine like terms. So you have x squared. Positive 4x plus 2x makes it a positive 6x plus 8. And the second one, you have negative 5, negative 3 makes it a negative 8x plus 15. Try not to bobblehead. Try to do it yourself. Just use mine to check your answers. Because let's see what you know, not what I know. The bottom stays the same. Nothing happens there. I can't do anything else inside the brackets and the parentheses. So I can the first one, since there's no coefficient, I can just drop the brackets. The second one, since it has a minus sign, I have to change every sign inside there. So it becomes a negative x squared, becomes a positive x, and a negative 15. Again, when you get rid of parentheses, the first thing you want to do is combine like terms. So we have x squared minus x squared. That's good. 6x plus 8x is 14x. Negative 15, positive 8. 15 is bigger, so it's negative. 15 minus 8 is 7. We have,
Would that be factored on top?
yes, always go as far as you can factoring because it makes numbers easier. So what can we factor out of the top? They both have a 7 in common. So take out a 7, leaving us with 2x minus 1. Because whenever you factor anything to see what goes inside the parentheses, you divide those terms. 14 divided by 7 is 2x. 7 divided by 7 is 1. So that's 2x minus 1. Now what do? I factor as far as I can. Has equals 0 on one side. Now I find my information. X-intercept. What's that?
I do have a question about earlier.
Okay. How far earlier?
When we had
On this page.
all the factors before we further up, right there. There's x minus 5 or x minus 5.
Here?
Why wasn't that? Yeah, or canceled out.
Good question. Very good question. In fractions, if we had that, what is 3 plus 5? So we know the answer is supposed to be 8 over 5, right? But if we cancel those, what do we have now? What do we have? No. When you cancel 5s, what are you left with? Are they the same answer? No. Because it has a plus or minus there, that makes it one number. You cannot, the only time you can cancel and reduce things is if they're multiplied together. So if we had 5 times 3 over 5, 15 over 5, that's the same thing as 3. So only when they're multiplied, not when they're added and subtracted.
So because earlier it was seen as minus x minus 3, x minus 5.
Right. And there's this minus sign here. So this part is it's kind of like this is my 3 part minus the 5 over 5. I can't cancel this one thing. And what you just said, Esther, most students would do that. They say, oh, look, I can see those, they look the same, so I can cancel them. The only way you can cancel them is if you can factor it out. That's come we always right here. Like in this one here, what we should have done is that we factor out a 7. Now we can look at can anything cancel. Since this is multiplied and that's multiplied, now we can see if anything cancels. And only then. Very good question. Since nothing cancels, we can now find our information. What's our x-intercept? Set the numerator equal to 0 and solve. What's that? Yeah, but 2x minus 1 equals 0. Move the 1 over and divide by 2. I mean, you shouldn't be surprised. You should. We've just spent how many hours? 20 days doing this. So you shouldn't be surprised on that's the right answer. But very good. What's the y-intercept? Set x equal to 0. Solve. So if we set x equal to 0, on top we have 7. What else on top? No. We set x equals 0. What do we have left on top? We have -1. On the bottom we have for the y-intercept, just erase everything that has an x. Just erase it. It doesn't exist. It's 0. So now what does this give us? The negatives cancel. So we have 7/20. Do we have a horizontal or oblique asymptote? How do we know when we have an oblique asymptote? What's the rule there? No. No.
Our bond.
No. Again, nobody's looking at the notes. What we talked about yesterday. Like I said, why? If you're not going to use it, don't take it. How do you find an oblique asymptote? Oblique asymptotes only exist if that's true. What does that mean? That means if the top exponent is bigger than the bottom by 1. If there's one more x on top than the bottom, then you have an oblique. That's the only time. How many x's do we have on top? How many on the bottom? We only have 1 x there, 2 x on the bottom. So there is no oblique asymptote. Do we have a horizontal asymptote? If so, what is it? No.
I was mistaking the oblique asymptote for the horizontal asymptote. But the oblique asymptote is the one that goes
Oblique, right. Oblique is a slant. It's a linear equation. You have to use long division. Yes, but the condition of when to use, you can't just go ahead and take a long division. You have to know when you have to take long division. You only take long division if this is true. If n the top is bigger than the bottom by 1. That's the only time. See, there's lots of stuff. There's conditional information that you have to put in your notes. That's what I said. You have an oblique if you have one more x on bottom than the bottom. On top than the bottom. Then you do long division.
Isn't it, if it's bigger than 7? It's,
That's what I have. If N. Bigger than N.
What does that mean? If n is bigger than m,
no,
what is n? You guys are saying n and m. What is n? What is m? N is the numerator degree, m is the denominator degree. Look at the conditions. How many x's do we have on top? How many on the bottom? So, is it which one of these three conditions is it? Top, middle, or bottom? Yeah. So in your notes, what is it when n is less than m? But look at your notes. What is your horizontal asymptote when the top is smaller than the bottom?
it's 0.
It's the x-axis. What's our vertical asymptote?
The bottom is X, positive 5. And X positive.
-4. It's opposite signs of what's inside the parentheses.
Yeah.
It's the same thing we did in chapter 1 when we did circles. Actually, I'm put down here to do this. So this is your horizontal asymptote. The vertical asymptotes all right, 5 and -4. Our x-intercept is at 1/2. Our y-intercept is at 7/20, which is very far down here. So here's that 6, 7, that -5. So now we have to graph our picture. How do we graph our picture? Our function, remember, is this. Seven times 2x minus 1 over x minus 5, x plus 4. Well, in the middle, we know we have an x-intercept and a y-intercept, and it has to approach our asymptotes. So what happens at further points? Does it go back up? Does it cross and go down like this? What happens?
Is it decrease positive?
Well, let's see. Let's just see. If at -1, if we plug it in there, is the answer going to be positive or negative on top? So it's -2 minus 1 makes it -3. So it's going to be a negative answer on top. On the bottom, -1 minus 5 is negative. -1 plus 4 is positive. So the bottom is going to be negative. So the top is going to go to positive. So it's going to look something like this. Because we have an x-intercept and a y-intercept. We know at -1, it'll be further positive. And I'm saying at 2, it's going to be further negative. Because 2 times 2 is 4 minus 1. It's going to be a positive. So the top is going to be positive. But the bottom, 2 minus 5 is negative. 2 plus 4 is positive. So the bottom is negative. So the answer is going to be negative. So it's going to be further down in the negative. So that's the middle part. That's the hard part. Now, on the outer range, on the other side of the vertical asymptotes, it's either going to be above here or below there. It has to do that. Since there aren't any x-intercepts. So we take our value, take a test value. If I plug in this into my equation and it's positive, then I know it's up here. If I plug it down here, I know it's down there. So on top, 6 times 2 is 12 minus 1. That's going to be a positive on top. 6 minus 5 is positive. 6 plus 4 is positive. So my answer here has to go like this. Because there is no x-intercept. And when I plug in 6, the answer is going to be positive. So it has to be above the x-axis. When I, again, on the other side of my vertical asymptote, I choose a value. I put in -5. 2 times -5 minus 1, -5 minus 5, -5 plus 4. All I care about, I care about the numbers. Is it positive or negative? 2 times -5 is -10, minus 1 is -11, times 7. The answer is going to be -77 on top. So it's negative. -5, -5 is -10. It's negative. -5 plus 1 is negative. Negative becomes a positive. So we have a negative over a positive. So this one's going to be a negative answer. It has to be down there. All I'm looking at is the answer positive or negative? If it's positive, it's above the x-axis. If it's negative, it's below the x-axis. So yes, really, there's nothing new we talked about here. It's just we put everything we've talked about so far into one question. You just have to know how to graph polynomials, rational polynomials. All right, that's it for that one. That's it for that chapter.
Wait, we're not gonna do the.
Oh, yeah, we haven't done that yet. Very good. I'm glad you said. So what are we looking for? Above or below? Look at this again. If you read this, how would you read this? 0 is greater than this. So I want this has to be less than then. So this is less than 0. So I want above or below the x-axis? Below the x-axis. Yes, just because it's on the right-hand side, that is the most common mistake students make. If you go with that way, then flip it. So you want 0 on the other side. I'm going to the left. So all of these are below the x-axis. So from -infinity to -4. Can I use -4? No, it's a vertical asymptote. Then from my x-intercept at 1/2, can I use that value? Yes, because it's an equality. So from 1/2 all the way up to 5, which is the next vertical asymptote. So my final answer is this. It's where the graph is below the x-axis. End of section, end of chapter. Any questions about these?